they want us to graph g of x using transformation. So what they mean is this: identify what the base graph is going to be, and your base graph is one of, I don't know, at this point you only know about 4 or 5 base graphs. One of them is a line. A linear equation is a base graph, which is the line. But one of the most basic graphs is y equals x squared, which is a quadratic. It's a parabola. So that looks like this. It goes, whoops, it goes like, drew that really bad. Let me try that again. It's going to go through 0, 0. It's going to go through 1, 1. It's going to go through 2, 4. It's going to go through 3, 9. And then it's going to be flipped over the... So that's what your base graph, that's a parabola graph. So when they give you a problem like this, they're either asking you, how is this transformed, how is your base graph transformed when you add a 4 to the inside? And this is where you have to, and you've gone through this, I'm sure, in class, you've gone through all the thing where you're doing X and your T charts, and maybe you've done it on your calculator. There's all kinds of explorations that you can do, but here's the long and the short of it is this. When you add something to the inside, you're moving left 4. So every single point on this green graph moves left 4. So this point right here at 0, 0, now that point is negative 4, 0. This point which was 1, 1, now it's negative 3, 1. This point which was negative 1, 1, is now negative 5, 1, etc. So the entire graph just moves left 4. That's the transformation. So the transformation for that graph is left 4. How about this graph? I'll do another color, purple. How about f of x equals x squared plus 4?
Up 4.
Right, now I'm adding 4 to the outside, not to the inside. See how this was inside here? This is outside, so this transforms it up 4. Every single point moves up 4. So this green graph, instead of 0, 0, it's 0, 4. Instead of 1, 1, it's 1, 5. Instead of negative 1, 1, it's negative 1, 5. And every point moved up 5. So that's that transformation. What if it had said minus 4? Instead of going up 4, it would go down 4. And your graph would have been down 1, 2, 3, 4, down here, and up like that. Let's do another one. If I have h of x equals negative x squared. Negative x squared means that I made the... Notice, is that negative on the outside, or is it on the inside?
Outside.
It's on the outside, right, because it's not inside the parentheses. This is a totally different problem. So let me undo that. That problem right there flips it over the x-axis. So that graph is going to be like this. That green graph, I just flipped it over the x-axis. What if my graph was, let me do this in blue, light blue. What if I had the parentheses around it? What's negative x squared with negative x's in parentheses? What's negative x times negative x? It's the same thing. It's x squared. And you know what it just did? You can't see it, but what did it do? It flipped over what axis? Flipped over the y-axis. And look at that original green graph. It's symmetric about the y-axis, so you didn't even notice it, that it flipped. That's because negative x squared and negative x quantity squared and the x squared are the same thing. So that's how you transform a graph. That's the transformations. And there's a couple other rules and a couple other tricks about it, but that's how you transform a graph. So let's take this one. Let's say m of x equals negative x plus 1 squared minus 2. That's a pretty tricky looking graph there. So here's how I would do this problem. Actually, let me make it a little bit easier, because that's confusing to have a negative on the outside. What if I have that graph right there? There's two things that happen. What are they?
Down 2 and to the left.
Very good. This negative on the outside of it makes it move vertically, and so that goes down 2, and then positive on the inside makes it move which way? Left 1. So your graph, which normally, let's do this in black, your normal graph would have looked like this. That moved left 1, so this point 0, 0 moved left 1 and down 2, so there's your new point. And so did every other point. I'm just going to rough sketch it right there. That's what that graph looks like, roughly. Now, eventually what you're going to have to do is find the x-intercepts and the y-intercepts. So how do I find the x-intercepts and y-intercepts for that? I'll go ahead and show you this. It's maybe more than you have to do right now, but let me show you how to do that. How do you find x-intercepts? Remember what's true about every x value here? What's true about every one of these points right here? What does the y value equal? The y equals 0 for both of these points, right? So if I plug 0 in for y and solve for x, I'll get my 2 intercepts. So let's solve this. How do I solve it? Don't distribute it out. Don't you dare distribute it out. Let's add 2 to both sides. Now, what do I get rid of? How do I get rid of the squared?
Square root.
And don't forget your plus or minus. That's where you get 2 answers from, because there's 2 points there. And then I subtract 1. So -1 plus or minus the square root of 2. Hey, look at this. -1 is right there. That's -1. And what am I doing? I'm adding the square root of 2, and I'm subtracting the square root of 2. That's why I've got 2 points there. And that's why it's symmetric to this point, -1, -2. That's your vertex, -1, -2, and I'm getting ahead of myself right here. But that's how you would find the intercepts. They're going to ask you eventually to do that. Find your intercepts. So your x-intercepts would be -1 plus root 2, 0, and -1 minus root 2, 0. Those are your 2 intercepts. And your y-intercept, that's easy. I'll do this in red. You just plug 0 in for x and simplify. 0 plus 1 is 1, 1 squared is 1, 1 minus 2 is -1. There's your y-intercept. 0, -1 is your y-intercept. So there are your 3 intercepts, right? But again, you don't necessarily have to do that quite yet. Good luck.